Hey guys, this video is going to be about the first satellites put into space. So first off, before we talk about that, we should talk about what a satellite is. So normally I think students will think a satellite is some sort of object with solar panels that travels around the Earth and spies on the Earth. And that's part of what a satellite is. Those are satellites. But really, a satellite is any object that orbits another object. So in this way, there are natural satellites like the moon. The moon is a satellite that orbits around the Earth. And also, the Earth itself is a satellite that orbits around the sun. So anything that's orbiting another thing can be a satellite. But we're specifically going to talk about man-made satellites. And so this is going to be the ones that you think of that are either taking pictures of the Earth or operating your GPS so you can figure out where you're going, or whatever else satellites do, including space shuttles and the International Space Station. They're also satellites. So very briefly, and if we were in class, I would explain this in more depth. Satellites orbit the Earth. If they didn't orbit, they would fall to the ground, or they would need an infinite amount of fuel to sit there and continuously hold themselves in space. The reason for this is that there is gravity 100 miles up in space, or 250 miles up, where the International Space Station is. Things are not weightless in the way that people think they are. Things are moving around the Earth in a circle. If you look at this picture of the little cannon firing a cannonball, kind of gives you an idea. So the first cannonball is fired to point A, but it falls to the ground. The second cannonball is fired to point B. It goes even farther, and so it hits the ground later because the ground is farther down. The third cannonball, C, is falling, but it's moving forward, and it keeps passing the Earth as it's falling and never actually hits the ground. So this is actually what orbit is, and this is what space shuttles and other rockets do when they go up in space. They travel around the Earth, constantly falling, but constantly passing the Earth at the same time at just the right speed to keep themselves going in roughly a circle. In fact, it's not a circle. Orbits are actually ellipses. That's one of Kepler's laws, but you don't need to know that for today. So this is how orbit works. So there is gravity in space. It's about 90% at about 100 or 200 miles up, about 90% of what it is on the ground. But objects are in free fall, and that's why everyone feels weightless. So in the 1950s, we understood that we finally had the technology where we might be able to put something into orbit around the Earth. And to get into orbit, you have to go about 17 or 18,000 miles per hour. This is a pretty high speed, so it takes a tremendous amount of fuel to get something into orbit. So there were two countries trying to do this, the United States and the Soviet Union. The Soviet Union you can think of as Russia, although it was bigger. It included a few other countries with it, but most of it was Russia. Nobody, eat your breakfast. So both countries were trying to get the first satellite into orbit, the first any object really into orbit, and they set kind of 1957 as their target year. The Russians, this was the 40th anniversary of the October Revolution, when the communists overthrew the Tsar in 1917. And the United States said it was the first, I forget what they called it. It was a year where all scientists around the world would work together. You kind of feel like they picked the same year just because the Russians picked it and we wanted to beat them into space. So the Russians were working on this object here called Object D. It weighed about 3,000 pounds, and they wanted to try and put this on top of a rocket and get it into space. But the problem is that's a lot of weight to get into space. It would have done some pretty cool things, but they eventually realized that they needed to go with something simpler and just get something up there. Because once you get something up there, then you learn a lot, and then you can make a bigger rocket that can carry something bigger up there, and then something like Object D could be put into space. So they settled on this tiny thing. It weighs about 200 pounds. It's a metal ball with 4 metal rods that are about, 3 or 4 feet long. And the ball itself is 2 feet wide. It's got a couple of radio transmitters. I think there was actually 2, and they would both do the same thing. I believe there was 2 for redundancy, but don't quote me on that. And what they would do is they would just put out this little ding, ding, ding sound, and anybody who was near where it was passing over could receive that signal. I don't know if a regular radio would do it. Regular radios go from 95 million to, or 90 million to 105 million hertz. You can look at 107 million hertz. You can look at the radio dial, right? You know, it goes from, it'll say 90 up to 107 or 108. I'm not sure what the frequency was of the signal, but countries could pick it up, and they would know that it was the Russian satellite because it was making that sound. So that would be their proof that they had succeeded. And they did succeed. In October 1957, they launched this satellite called Sputnik-1. So this is the first man-made object to actually go into space. And as I said, it's about 84 kilograms, is about 200 pounds. So it took, thousands and thousands of pounds of fuel and lots of expended rocket parts to get a very small object into orbit. And that's how putting things into space is. You spend a lot of fuel and you have pieces of rocket that are thrown away afterwards that fall to the ground to put something very small into space. It's very expensive. But they beat us there. They did it, and this was the first time. So what were we doing? Well, we had separate groups, the Army and the Navy, who were competing. There was no Air Force yet. I don't think the Air Force existed yet. Actually, no, the Air Force did exist. Okay, the Air Force was part of it. That's in my notes here. Sorry. Yeah, the Air Force was created, I think, shortly after World War II, so this would be like 10 years later. But the Army and the Navy were the two big competitors, and the Army had a slightly better team and a better rocket. The Jupiter rocket, which would become the Juno, or do I have that backwards? The Juno eventually became the Jupiter. I don't know, one or the other. Anyway, their rocket was better. The Navy had the Atlas rocket, but it saddens me to say the Navy was not doing as good a job. But the American people, and therefore the politicians generally do things to make people happy so they get reelected. That's how democracy works. And the American people did not want the Army team to lead this race into space because the guy who was leading the Army team, if you remember from our last lesson, was Wernher von Braun, who was a former Nazi. And this would be sort of infuriating for some and embarrassing for others, and they didn't want him to be the guy. So the Navy got their first shot instead because people were biased against von Braun. And the Navy rocket, the Vanguard rocket, well, I'll tell you what. Where is it? I have a video for you. I'll try and post a link. You could actually just Google it on YouTube, first Vanguard rocket launch, and you'll see what happened to this one. Actually, do I have it? Okay, yeah, so it didn't go so well. Can I play a video while I'm making a video? I think I could do that. Yeah, let's just watch this because it's a little bit insightful into rocket technology.
A large segment of the nation's scientists, engineers, and production during the year.
We'll skip ahead to the actual launch.
Promptly announced them. The first and most spectacular of these was Vanguard at the end of 1950.
So you can see Vanguard did not work out so well. So that was the Navy's rocket. So then finally, after the Russians beat us in space in October, they agreed, okay, we're going to give the job to the Army because, we want to tie up the score with the Russians. We want to at least get into space. Maybe I'll show you this quick launch too of the.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
So this is the Army's rocket. Explorer 1 was the name of the satellite we put on top of it. And as you can see, that was a nighttime launch, but it was a successful launch, and that put our first satellite in a few months after the Russians in 1958. So that's it for the Juno rocket. That was the one that carried the Explorer up. So that's it for the first rockets. The first satellites put into space. A few years later, people would start trying to put people into space, and that'll be the subject of our next lesson. So we will stop here.